Just a quick video. This is a chassis I developed for the Scalextrics for Schools school competition. So what I'm doing here is I've taken an existing car, shortened the wheelbase, because what I wanted to make is a sort of development of the Made Formula Schools project. So that was using radio control car, obviously with the expense of motors and things are a bit more pricey. Then you've got servos, or one steering servo, electronic speed control, and then a transmitter and a receiver, and then a 4-cell nickel metal hydride battery. So it's a 4.8 volt battery, and then you need chargers and things like that. So there is an expense in setting up that project, but I can see these two projects working quite well because there's so many skills that are sort of crossover between the two in terms of not injection molding, just using 3D printers to produce printed parts and complicated sort of plastic assemblies, carbon fiber or glass fiber, gear ratios. You've got the sort of same sort of bevel gear and spur gear to make the gear reduction from the motor. A little tiny bit of soldering as well, and you've got the pickups and things like that. But what I've done here, this is really a prototype, and I'm sort of sharing these ideas because it might help other schools develop the project themselves. So I'm using an off the shelf. I can't remember the manufacturer, and I'll put that in the comments or in the description for the video. But it's a little sprung pod, so you've got a little bit of suspension on here. It's obviously sitting on the pickup at the moment, so it's the ride height is all wrong. But you can see it's just got a little bit of movement in there. And then there's two tiny springs here, and this is just a bolt here with a little tiny nylon lock nut on top, so you can sort of adjust how much movement you've got in there, and you can stiffen it up by tightening those up. With this car, I wanted to base it on the Mini, so I've used a sort of similar shape bumper front and back. So you've got the little round bumpers, so they'll project beyond the body shell, so it looks more like a little mini stock car. And on here as well, I've used a factory part for the front axle there, but that can just be replicated from a little tiny piece of aluminium angle. And if you've got a fixture on a lathe for doing some milling, you can drill the holes nice and precisely using the cross slide on the lathe to index the holes. You can also make some little fixtures and little jigs, so you can switch those round and then maybe clamp the two together with a little toolmaker's clamp, so you can drill through, so you get the alignment more precise. The wheels on this, I'm using aluminium turned wheels. You could turn those on a lathe yourself. If you've got a CNC lathe, that'd be perfect for making a number of these. The collars and things, I just bought some of those in because I wanted to get the project up and running. What's quite interesting here, I've used carbon fiber for the mounting point for the motor, and then it bolts onto the chassis here, and then I've tapered that or wasted that away a little bit there, so there's less carbon fiber, because carbon fiber is quite rigid, it's quite stiff. There wasn't enough give in the material, but you could alternate glass fiber or even styrene if you wanted a bit more movement in there, so it's a little less restriction on the travel. What I've done here, the front end, I was playing around with having a sort of floating pickup, so there's a bit of damping and a bit of movement in there. I don't know if that's a real requirement. It was based on some of the 1/24 slot cars, so I was going to have a central fixing there, and then possibly some play in here, but that might just be my means of having an O-ring and a nut so it can adjust, so it just gives it a little bit of flex in there, so it's not completely rigid. Because what you don't want with these stock cars is if everything's fixed solid, when it goes around a corner, it tends to jump and judder, and once the back end's bouncing and jumping, it just tends to de-slot, so it wants to overtake the front end because there's no resistance on there. So sometimes you can just achieve that by just slackening off the body screws a little fraction, so there's just a bit of movement between the body and chassis, so it tends to keep the tyres in contact with the track surface. But obviously with adjustable suspension on here, you can run it, you can take the springs out, you can screw it right down so it's solid, you can get a sort of a number of lap times there, work out a sort of average, maybe even have a couple of students racing the car so they can sort of see what the average is, and then you can play around with adjusting the springing there, or even alternate different springs as well. What you can do with this as well, on this carbon fibre plate I've got a cut out for those projections there. and there's a spacer here as well, so you can play around with it, trimming in the ride height to get it up higher or lower, and depending on the ride height you might have more or less suspension as well. So there's a few little areas you can tweak. And with the front ride height, these little angle pieces here have got a threaded a little tiny grub screw that goes in there, and then you can just adjust that. There's no bearing on the front, it's just bears on the plastic, and then you can screw this up and down, and then that will dial in the ride height. And obviously with the pickup here, at present this part is made out of acrylic, but I wanted to machine this out of brass, so it gives a little bit more weight, and it makes that section there much more durable, because I've found that when the cars come off the track, obviously the guide flag projects beyond the wheels, so that hits the ground first, and then that can snap that piece. And once that's snapped and the chassis is all in one piece, and it means there's a lot of disassembly, which is a pain, and it's when you disassemble the cars that the leads come unsoldered and things like that. So I wanted to have that bolted in, so it's just a case of undoing the screws, and then you can change the front end out. I'm using carbon fibre for this just because it's got a bit more of a sort of it's a bit more of a cool factor than using styrene, and it is very dimensionally, it's very flat as well, so it's quite nice if you're running these cars very low to the track. You don't have any distortion or any warping in the chassis. If you use something like a styrene sheet, it would tend to move and it would be dragging on the track. You could alternate, or you could use just glass reinforced plastic or fibre reinforced plastic, which would do the same thing, but obviously for the size of the part, carbon fibre hasn't got a large expense. It's only maybe £25 a sheet. Sheets around about A4 or A3 size, somewhere in between, and you can cut a number of cars out of that. But what I'd like to say, if you're prototyping these and you've got a laser cutter, it's good to use something like 1mm MDF or 2mm MDF to cut all the parts out. Build it up as a sort of running test bed, and then when you're really happy with that, then you can invest in a carbon fibre for maybe 6 or 7 of these cars, and you can use those as a little test rig, and then you can change gear ratios and things like that, or even you might find that suspension works better, or you might have something different, and then you'll use that test rig as a development sort of base to make their own student designed cars. And I think with having something like a floating axle, or some means of adjusting the pressure onto the front tyres, because you just really want these front tyres just to touch. They're almost like stabilisers on a bicycle, so you don't want them running on the ground at all times, but if it just leans on the corner as the weight bears across to this side, you just want it to touch, so it just gives it a little bit of control. It's not just floating around, and it also maybe takes off some of the weight from the pickup as well, so it changes the weight distribution. What will be interesting as well, there's obviously no differential on the back axle, but it might be interesting to make a split front axle and then have a tube with bearings to actually locate the ends of the axle, just so you've got independent movement on those tyres as well. So that would make up for the fact there's sort of this just solid, so you'd have differential speed of the tyres moving around the corners. It could actually make a ball differential for the rear end. That'd be quite small, but the parts are, because they're so small and cheap, you wouldn't be using up lots of materials. But yeah, it's just probably one of these things I'll work on. But you'd have to fit it in between the wheel and the motor support there. But you could even these wheels are dished in quite a lot, so you could fit it the bearing inside there. And what I think I'd do is have a solid axle, and then just have like the spring washers, so it just the wheel itself bolts onto the one side of the ball diff, and then the axle can just rotate inside the wheel. So yeah, this is just quite a fun little car. Well, it's going to have the vacuum formed mini body shell on it. One thing about having it based on the Mini is it just makes it smaller as well, so you can see you're not using as much materials as well. And from the base here, you can see that the motor pod is cut out right through the chassis here, but there is once those little tabs are cut out as well, then there's a scope to have this a little bit more movement below the level of the floor pan as well. And then once you've got that cut out, then you can tweak that in terms of the suspension travel. And you can just see those tabs there. They're like a stop, and it touches on the sort of chassis plate at the moment. But a quick little video, just a few ideas, and hopefully by sharing these ideas, it might help other schools to just sort of think, oh, it's something they might want to consider doing. And thankfully there's a supply for the parts, so it's quite good to get these cars up and running. One small difference between this chassis and the Scalextrics for schools parts is this one actually uses little brass sort of spherical bearings which are pressed into the motor pod, and they're quite a close tolerance on the axles, so there's no knurling on the ends of the axles. The axle slides right through, and then the wheels are located with a little grub screw. But I think what it might be quite nice is to 3D print some wheels for this that pick up on or take the same size tyres as the Scalextrics for schools kits, but then you can just have a little grub screw in there so you can switch the wheels off quickly and easily, and then you might just turn some little bearings just for making a test rig. But once the wheels are pressed on and into the motor pod, you can't really disassemble those, so I think it's a good idea to have something with a grub screw on it there. Just makes it a bit more flexible when you're kind of prototyping these cars. And I think by having them as in a number of sort of tweaks you can make, if you can switch the wheels and tyres around, it's easier to change the sort of tyre. You might want to put tyre compounds on there front and back, so you want a little bit more slip on the front tyres and a little bit more traction on the rear tyres, and it just enables the students to swap out those components so they're not just running a sort of just a standard ready-made chassis. Hopefully if students take to this, and I think this could be even a sort of lunchtime club with A-level students, and then they could be producing more of the carbon fibre parts and then machining more of the aluminium motor pods and things like that. And obviously the wheels and tyres, the wheels could easily be turned on the CNC lathe, and that would be teaching them another sort of industrial process and using some of the 3D CAD software as well. But I can really see this working well in accord with the Formula schools as well. There's more expense with this, but I think as an initial project, and if we can get the parts from Hornby so they're affordable, if you run this right across Key Stage 3, maybe in a Year 9 project with possibly like I don't know, you're buying in hundreds of these rather than half a dozen, then the students that are really interested in this could take that further. And then I think having a club where they can either work on something like this with more of the design, or then moving over into the Formula schools, because then that's much more, there's more scope in them. They're both terrific projects, but I think having the slot cars is always going to be the kind of negatives around about, oh, it's just running around in circles and things like that. With the radio control element, and even moving towards the 4x4 in schools as well, there's more scope for chassis design and more creative input into that project. But they are both excellent projects in their own way, and I think these projects really deserve to be supported by schools, and there really needs to be a manufacturer or some industrial link providing some support in terms of sponsorship and sharing the rules and regulations to make this more sort of accessible for schools. But both going to be two little minis, very sort of similar, obviously different scales. This is 1/12 and this is around about 1/32.